Imagine packing for a very special trip. Your destination, the past, or maybe the future. You'll need some essential items. First, a reliable time machine, of course. Next, a map to navigate the twists and turns of time. Finally, a healthy dose of courage. Because time travel, if possible, would be an adventure like no other. For centuries, humans have been fascinated by the idea of time travel. We see it in myths, legends, and literature. Who hasn't wished they could go back and change a mistake, or get a sneak peek at what the future holds? But is time travel just a fantasy, or could it be within the realm of possibility? To answer this, we need to turn to science. Specifically, to the mind-bending world of Albert Einstein and his theory of relativity. Let's see what science has to say about our chances of becoming time travelers. Fasten your seatbelts, because things are about to get strange. In the early 1900s, Albert Einstein revolutionized our understanding of the universe. His theory of relativity, presented in two parts, shook the very foundations of physics. The first part, special relativity, deals with the relationship between space and time. It says that time is not absolute. In other words, time doesn't tick at the same rate for everyone everywhere. Imagine two identical clocks. One stays on Earth, while the other takes a high-speed trip on a rocket. Einstein's theory predicts that the clock on the rocket will tick slightly slower than the one on Earth. This phenomenon is called time dilation. The faster you travel through space, the slower you travel through time. It's like traveling through a cosmic molasses that gets thicker the faster you go. While the time difference is minuscule at everyday speeds, it becomes more significant as we approach the speed of light. This isn't just a theoretical concept. Time dilation has been experimentally verified using atomic clocks on airplanes and satellites. Time dilation might sound like science fiction, but it's real. We experience tiny amounts of time dilation in our everyday lives. Earth's gravity causes time dilation, shown by atomic clocks. Time moves slower at sea level compared to a mountaintop. GPS systems account for time dilation to stay accurate. GPS satellites' clocks run faster than those on the ground. Without correction, GPS would be inaccurate. Time travel is happening on a small scale. The challenge is to amplify these effects for practical time travel. If speed affects time, so does gravity. The stronger the gravitational pull, the slower time ticks. This leads us to one of the most extreme objects in the universe, black holes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. As you get closer and closer to a black hole, time dilation would become more and more extreme. From your perspective, time would seem to slow to a crawl compared to someone observing from a safe distance. If you could somehow survive a trip to a black hole and back, you would have aged far less than those you left behind. You would have effectively traveled into the future. But what about traveling to the past? That's where things get even trickier. Some physicists have theorized that black holes might be connected to other points in space-time through hypothetical tunnels called wormholes. Let's delve into the realm of wormholes and see if these cosmic shortcuts could hold the key to unlocking the past. Section 5: Wormholes, Shortcuts Through Space and Time. Imagine folding a piece of paper in half. Now imagine a tiny worm burrowing a hole straight through the folded paper, connecting two distant points. That's the basic idea behind a wormhole, a theoretical shortcut through space-time. While Einstein's theory of relativity allows for the possibility of wormholes, no one has ever observed one. They remain purely theoretical. If they do exist, wormholes could connect not only different points in space but also different points in time. Imagine entering one end of a wormhole and emerging in a different time period, perhaps witnessing the age of dinosaurs or meeting your future self. Sounds like something straight out of Doctor Who, right? While the concept of wormholes is fascinating, it's important to remember that they are still firmly in the realm of speculation. We don't know if they exist, let alone if we could manipulate them for time travel. Section 6. Building a wormhole, easier said than done. Even if wormholes do exist, creating or manipulating one would be a monumental task. Some physicists believe that wormholes might require exotic matter with negative mass energy density to keep them stable and traversable. Think of it like trying to inflate a balloon underwater. You need something to push against the water pressure. Similarly, exotic matter might act as a scaffolding, preventing a wormhole from collapsing in on itself. Unfortunately, exotic matter is, well, exotic. We haven't found any evidence of it in the universe yet. And even if we did, harnessing its power to create a stable wormhole would require unimaginable amounts of energy. So while wormholes offer a tantalizing possibility for time travel, the practical challenges are immense. We're a long way off from building our own time-traveling DeLorean. Section 7. The Grandfather Paradox. Can you change the past? Time travel isn't just about overcoming technological hurdles, it also raises some mind-boggling paradoxes. Perhaps the most famous is the grandfather paradox. Imagine you travel back in time and accidentally kill your own grandfather before your parent is even born. Without your grandfather, your parent wouldn't exist, and neither would you. But if you don't exist, how could you have traveled back in time to kill your grandfather in the first place? It's a logic loop that ties our brains in knots. This paradox highlights the potential contradictions that arise when we tamper with the past. Some physicists believe that time travel to the past might be impossible, precisely because of these paradoxes. Others have proposed solutions like the many worlds interpretation, which suggests that every time you travel to the past, you create a new, parallel timeline. The grandfather paradox isn't just a thought experiment for philosophers. It has profound implications for our understanding of cause and effect, free will, and the nature of reality itself. Section 8. Time travel in science fiction from H.G. Wells to Back to the Future. Time travel has been a staple of science fiction for over a century. From H.G. Wells's The Time Machine to the Back to the Future trilogy, writers have explored the possibilities and perils of journeying through time. These stories often serve as cautionary tales, reminding us that altering the past can have unintended and potentially disastrous consequences. They also explore the philosophical implications of time travel, like the nature of free will and the meaning of destiny. While science fiction often takes liberties with scientific accuracy, it can inspire us to dream big and imagine what might be possible. Who knows? Perhaps some of the technologies and ideas explored in science fiction will one day pave the way for real-life time travel. Until then, we can continue to explore the wonders of time travel through the lens of imagination and creativity. Section 9. Time Travelers Among Us. The idea of time travel is so captivating that some people believe it's already happening. There are countless stories and online forums dedicated to alleged sightings of time travelers. Some point to anachronistic artifacts, objects that seem out of place in time, as evidence of time travelers leaving their mark on history. While these stories are entertaining, there's no scientific evidence to support the claim that time travelers are walking among us. Extraordinary claims require extraordinary evidence, and so far the evidence for time travel remains elusive. Still, the possibility, however remote, sparks our curiosity and imagination. It's fun to imagine a world where time travel is real and to wonder if we might one day encounter visitors from the future or the past. Perhaps someday the line between science fiction and reality will blur even further. Section 10. The Allure of Time Travel. Why we dream of other times. Why are we so fascinated by time travel? Perhaps it's the allure of the unknown, the desire to experience different eras and witness historical events firsthand. Or maybe it's the longing to right past wrongs, to relive cherished memories, or to catch a glimpse of what the future holds. Time travel represents the ultimate escape from the constraints of our present reality. It allows us to imagine a world where the past is not set in stone and the future is not predetermined. Whatever the reason, time travel continues to captivate our imaginations and fuel our dreams of adventure and possibility. It's a testament to the boundless potential of the human spirit and our insatiable curiosity about the universe and our place within it. Perhaps someday, we'll unlock the secrets of time and embark on journeys that defy our current understanding of the cosmos. Will we ever become Time Lords? Is time travel possible? The answer is complex and ever-evolving. Einstein's theory of relativity suggests time travel to the future is theoretically possible. Time dilation is real, but large-scale temporal leaps remain elusive. Wormholes offer a glimpse into potential shortcuts through space-time. The challenges are immense. Time travel to the past remains uncertain. Paradoxes raise questions about causality and reality. The pursuit of time travel continues to inspire scientific inquiry and our imaginations. Will we ever unlock the secrets of time travel? Share your thoughts below.